Hello everyone. Today we're going to discuss Chapter 3 of the EasyBuilder Pro user manual. Within this section, we'll demonstrate the basics of project configuration, and then review how to test your project through simulation, and then download it to your device. Let's get started by opening EasyBuilder Pro. And so initially when you open this application, you'll be prompted to select an existing project file or open a new project. Today, we'll go ahead and start a new project by selecting New in the top left corner. This will open our New Project window, where we can select the HMI that we'll be using within our project. In this demonstration, I'm going to select a CMT 3072, and then click OK in the bottom right corner. Our new project will then load and open by displaying our system parameters. The configuration of your system parameters is an integral part of your project. From within our Device tab, we can add remote HMIs, local devices, or even remote devices, depending on the structure of your device list and your application. To establish communication to your PLC, we'll begin by selecting New Device/Server. At the top, you can name your device to distinguish it from other devices within your project. And in the center, you'll notice our device type drop-down list. Selecting this list will open a new menu where you can search for the PLC or protocol used in your application. After identifying the correct driver for your project, you can click OK on the bottom right and the driver will be displayed next to device type. Just below this, you can select the connection interface between the HMI and your device by selecting from the drop-down menu next to IF. And after an interface is selected, you can then configure IP or COM settings in the box outlined below. Once the initial setup for your driver is finished, select OK on the bottom right and the PLC will be displayed within your device list. If you're using a tag-based PLC, then after configuring your driver, you'll notice an Import Tags and a Get Tag Info button at the bottom of your device list. The Get Tag Info button should only be used when you have established an Ethernet connection between your PLC and PC. This works by retrieving tag data directly from the PLC itself. In most cases, we recommend using the Import Tags button, which will allow you to import a tag file that you've previously exported from your PLC project. Once our tags have been properly imported, we can then modify other aspects of our project from within the system parameters. Within our Model tab, we can convert our project so that it can be downloaded into another HMI model. Just below this, we can support communication between our current HMI and a remote HMI of a different series. And on our CMT series HMIs, we can establish communication to a printer within this tab as well. Next, we have our General tab where we can define a startup window, backlight and screensaver settings. And within our System tab, we can set an initialization macro, hide the system settings button, or even disable the ability to upload the project, thereby protecting your intellectual property. Our Remote tab lets you configure some of the HMI's remote access settings. And our Security tab will allow us to configure a project password or configure operator login information. That's more or less a general overview of the basic features found within our system parameters. And I encourage anyone getting started with EasyBuilder Pro to explore this menu. And if you need more information about any of the functions or features, you can use the Help button on the bottom right. The Help button used within almost any object will call an additional window that allows you to click on certain features to reveal more information. This is an incredibly useful and often overlooked tool that can clarify the function or control of the features within each menu. With communication to our PLC properly configured, we'll go ahead and close our system parameters and evaluate our work area. As it's displayed, our work area showcases a small purple screen in the center, to which we can add the objects necessary for our application by selecting from the Object drop-down list or by selecting the Object tab itself. As an example, I'll select my Object tab and then select a bit lamp. Starting from the top of our General tab, our bit lamp in this example can be switched between a bit lamp or toggle switch by making the appropriate selection above. Just below, we can set the read address, which could be a local HMI bit or an external device, or even a PLC bool tag. And just next to our read address, we'll find our Settings button. This button will open an additional menu where we can access system or user-defined tags configured within the local HMI by selecting the appropriate checkbox and then searching within the drop-down list directly in front of address type. And since this isn't necessary for our demonstration, I'll revert this back to our local bit register LB0, and we'll go ahead and close our settings menu. At the bottom, we have our blinking section, which we can also consider as our attribute section as well. And heading back to the top, we'll select our security tab, which reveals different security limitations that we can use to protect this object. I can enable or disable this object depending on the state of a specific bit object, or limit access depending on the security clearance of the operator logged in. Next to this, we have our Shape tab, which we can use to assign a specific picture or shape to this object. And the last tab is our Label tab, which we can use to add a custom state-specific label onto our object. With the object's configuration properly explained, I'm going to select OK in the bottom right to save our object's configuration so that we can place this onto our work area. After our menu is closed, I'll move my mouse to the area in which I'm going to place my object, and then click on my mouse to position our lamp. With our lamp placed, let's go ahead and open another object. And this time I'm going to select a numeric object from my Object tab. With our numeric objects menu open, you might immediately notice several tabs that are shared between objects: the General tab, Security tab, and Shape tab. As before, within our General tab, we can configure the read and write address of the device we're communicating to. And our Security tab provides us with object-specific security, and our Shape tab will allow us to configure a custom shape or picture for our current object. Let's add our first PLC tag within this object. To do this, I'm going to select the drop-down list next to Device. And within this list, I'm going to select the PLC that we've added within our project. Now, just underneath this, I'm going to select the list next to Tag, which will reveal the numeric PLC tags available for use within our project. And I'll make a selection from this list. And now our object will display information from our selected PLC tag. Within our object's configuration menu, you'll notice we can enable a notification bit at the bottom of our General tab, which is explained by the fact that each object possesses its own unique features, some of which may lie within a tab specific to that object. Some examples of this can be found within the Data Entry, Format, and Trigger Action Setting tabs of our numeric object. Selecting our Data Entry tab. Within this tab, we can define a specific system keyboard to be used within this object. Our Format tab is perhaps one of the most important tabs of our numeric object, because within this tab we can configure the data type of our displayed data by selecting the device data format list at the top of our tab. Towards the center, we can establish a conversion method via interpolation or macro subroutine. And on the bottom, we can specify the high and low limit of our device, which should correspond with the digits within the display format section, where our decimal point configuration is defined. The next tab we'll take a look at is our Trigger Action Settings tab. This tab is unique to our CMT series and will allow your object to perform a specified action or a list of sequential actions before or after the object sends data to its predefined write address, meaning the address we defined within the General tab. Next, I'll open our Font tab, which is a tab shared within the ASCII display object. And within this tab, you can set the font size, color, and alignment of the characters displayed within your object. With our object configuration explained, let's go ahead and close our object by selecting OK in the bottom right corner. And then we'll place our object onto our work area as we did in our previous example. Within our next example, I'm going to demonstrate how to create your own tags within our address library. To do this, I'm going to be using the HMI's local registers, but tags can be created for any device without predefined tag names. To create our tags, I'm going to begin by selecting our Project tab. And you'll notice within our Library section, we have a selection for device addressing called Address. By selecting our address library, a new menu will open where we'll select user-defined tags. And on the bottom of our new menu, I'm going to select New, and we'll create a new UDT within our program. Now again, because the PLC within our object already possesses custom tag names, we cannot reconfigure a set of UDTs to replace these tag names within our project. However, if we had a non-tag based device within our project, such as a generic Modbus device, we could build a set of UDTs to identify the registers used within our project. Within our tag dialog, I'll create a custom name for this tag. As an example, I'm going to call this Pressure Setpoint. And next to Device, I'll use my local HMI for this example. I can define this as either a bit or word data, and I'll select word in this example. I'll leave my address type as LW and my address at 0, but I'll define my original format or data format as 32-bit float. On the bottom of this menu, we can select a read or write conversion that can utilize macro subroutines within our project. And for this example, I'll enable this and set my read conversion as a conversion from PSI to ATM, which will be accomplished via a macro subroutine I've configured within my project. When I'm finished, I'll go ahead and select OK in the bottom right corner, and we'll have successfully added a custom UDT within our project. Now that our UDT has been added to our address library, let's go ahead and close our menu and assign our tag to the numeric object on our workspace. To do this, I'm going to select our object, and once our General tab is open, I'm going to select Settings again, and within our Settings dialog, I'll select User Defined Tag. And from our address type drop-down list, I'll select our pressure setpoint tag. And it's as simple as that. Our UDT was defined as 32-bit float data, and heading to our Data Format tab, you'll notice that our data is automatically set to 32-bit float. With device communication, tag import, and tag creation covered, I think it's time to get an overview of the system layout and commonly accessed tabs within EasyBuilder Pro. Starting with our Home tab. In this tab, we can access the system parameters of our project, which is where we configured our PLC driver. And we also have a drop-down menu that allows us to quickly select and add a new object within our project. In the Arrange section, we have various tools that will allow you to align, arrange, or manipulate objects within your project. And if you're ever curious as to a button's particular function, simply hover your mouse over the button and a brief description will appear. And of course, on the far side, we have font, state, and language tools. The font section allows you to manipulate text or characters within an object by simply selecting the object and then making the appropriate adjustments within your toolbar. The state and language utility allows us to change the specific image or label state as well as the language state for all objects within your project. This will allow you to preview how all objects will look outside of their default state. Switching tabs will take us back to our Project tab. And here you can access some additional language settings on the left-hand side. In the center, we can build a compiled project file, test our project through simulation, or even reboot the HMI. And on the far right, as shown within our previous demonstration, we have our system libraries. Our Object tab, as is implied, holds the objects available within our project. Most objects represent physical buttons you can push or display objects that showcase data. But some objects, like our PLC control, data transfer, and action trigger, perform actions in the background. Selecting our Data/History tab will reveal a large selection of different ways to log data within your project. Within data sampling, you can configure multiple sampling objects to log data from several devices at once, which can be displayed within a trend display or historical log. Our event alarm log can be used to log and display important events within your project. The recipe database is used to create recipes within your project. Multiple recipes can be configured in several ways and are used to store recipe data within your HMI. We can track operator actions within our operator log settings, and it's worth noting that all of these can be backed up to an external storage device such as an SD card or USB, and most can be exported as a CSV file. This can typically be accomplished by using the backup objects in the center of this tab. And on the far right, you'll notice our database section. Within this section, you can add one or more SQL servers to your project. And this is used to stream information from our data sampling objects or upload SQL query information to a central database. It's important to note that you must have an applicable device to add a SQL database within your project, such as our CMT 3072. Skipping over our IIoT/Energy tab, I'm going to select our View tab. Although it may not look like much, the View tab is an integral part of our system's layout. Within our View tab, we can access, add, and remove various toolbars, labels, and design elements within your project. As an example, if you feel like you're missing an important toolbar within your project, simply check the box next to this toolbar, and the utility will present itself on either the left or right side of your window. And while we're here, let's talk about some of the most important toolbars you'll use within your project. The toolbars I'd like to focus on are our address grid, window tree, shape, and picture utilities. Starting with our window tree tab on the left side of your screen, this tab allows us to navigate our project, create new windows, or delete existing windows, as well as configure the settings of any current window. Our address grid will show us what objects are tied to each register within an external device or our local HMI's internal registers. It also displays the location of each object within your project. This tool is incredibly useful for finding address-related issues such as overlapping within your project. On the right-hand side of our screen, we have our Picture and Shape library tabs. These tabs help to find and use various pictures and shapes from the system libraries within EasyBuilder Pro. Our picture library specifically will even allow you to pull images directly and add them into your project. This can be helpful when adding custom images, such as company logos, onto your work area. And of course, you can also change an object's shape or image quite easily by selecting the object first, locating the shape or image you'd like to use within these tabs, and then double-click that image. Since we can now easily navigate EasyBuilder Pro, let's head back to our Project tab and see how simple it is to run a project simulation. Before we run our simulation, we'll need to save and compile our project, unless we tell EasyBuilder Pro that we'd like this to happen automatically. We can do this by selecting File, Preferences, and then ensure Automatically Save and Compile the Project is selected. And with that configured, let's select Offline Simulation. As you'll notice, our simulation opens and we can now test our project. And in case you want to test the project online with your PLC, we would select Online Simulation instead, which can be found within our Project tab as well. The next topic I'd like to discuss is how to download the project to your HMI. Now, before a project download, like your simulation, you'll need to ensure your project is saved and compiled. And if you've already configured this to occur automatically, all you need to do is select Download at the top of your Project tab. Once the download menu is displayed, simply enter the HMI's IP address or select HMI name to search for the HMI on your local network. Once the HMI is identified via either method, select Download at the bottom of this menu and your HMI project will begin to download. Upon completion, the display at the top of this menu will notify you when the download has finished, and you should now be able to access the project on your HMI. Following our user manual, the last topic I'd like to discuss is how to upload an HMI project to your computer. This is another feature that is fairly simple to use. And to begin, we'll select File in the top right corner. And within this section, we'll select Upload. Once our upload menu is open, we'll need to define a location for our compiled project file. Then, we can either enter the HMI's IP or search for the HMI on our local network. And once the HMI is found, we'll select it and then select Upload on the bottom left. And as before, our information display will notify us when our upload is successful. And it's important to note, if you receive an upload error during this process, this could mean that the original developer of the HMI project disabled upload functionality, meaning that this project cannot be recovered from the HMI and must be requested from the original developer. We can now access the compiled project file from our HMI within our chosen directory. The file uploaded must also be decompiled before you can modify the project within EasyBuilder Pro. To do this, you will need to select the File menu within EasyBuilder Pro and then select Decompile from the drop-down list. In the following menu, specify the compiled project file and the chosen directory of your new application, after which you may select Decompile. Be sure to check the description for quick links to different topics within this video, as well as 2 separate videos that explain in depth the various features within our download utility, as well as our CMT viewer application. And always, if you found this tutorial helpful and would like to see more, head on over to our YouTube channel and select the playlist tab. Feel free to check out our website as well for free demo projects, user manuals, and more. Thank you for watching.